So graph this. So like I said, we'll be looking at the linear over quadratic today, and we'll look at quadratic over linear on Thursday. So graph this all on one decimals. Then for each of them, I want you to observe the horizontal asymptote. And if there are ways, or there is a way you can get the vertical asymptote as well. Okay. So you can put everything together, like I said, and let's see how it goes. So once you put everything in the decimals, let me know so that we could discuss it. Okay. This will be a quick one. It's not something that should take our time.
This is Daniel. Finish.
Yes, sir. You finished? Okay, let's wait for others. So you start your observation, look at your domain, and write down the equation of the asymptote. No, you don't have to write down, just note it like in your mind, something like that. Okay. I'll be asking the questions, so I want each of you to respond. Maybe we take A, B, C, D like that, and we can do E and F together. Okay, so maybe Alex will take A, Yanko will take B, Kada, can you take C, and Elson will take D. Then we do E and F together. Right? So while I'm waiting, I'm going to be putting the functions on decimals as well. I may be taking this off my screen, so I'll send the screenshot to the WeChat. So the screenshot is in WeChat because I will need my screen. So x over x plus 5 x plus 1 let's see. Is everyone ready?
Almost one more.
Okay.
Yes.
So,
Oh, and also, Mr. Daniel,
yes, sir.
remember before when we were doing the log thing, you told us to look for why the log suddenly ends.
Why the log what?
Like the graphing.
Yeah. Yes, I remember.
And like it suddenly ends. Last night I did some experimenting, and it says -1, and then on the Y it says undefined. So it's not a computer glitch, but I don't know what it is.
Oh, the graph that wasn't extending, right? Is that what you're saying?
Yeah. The one that stopped.
Okay. So let's have this when everybody's back. Please remind me on the first day so that others can learn from your investigation. Understand?
Okay.
Please take someone should remind us, please, so that the SL group can also learn from it. That's very nice of you. Thank you, sir.
You're welcome.
3x. Okay, 9. All right. Ready?
Yeah.
Graph is so cool. Alex, is your graph cooler than mine? I don't think so.
Let's have a battle.
I think
Okay,
my
let's
graph
start.
is the coolest.
Right, you wish. You wish. Okay, so this is the first one. Alex, so let's look at the question. The question says, what is the domain? Alex, what's the domain, quickly?
The domain is negative infinity to -1, union -1 and 2, union 2 to infinity.
Union 1 and 2. I love that. Does everybody understand what he said?
Can you say it
Yeah.
again?
Yeah, Alex, so you're going to say it again. Let me put the whiteboard. Yeah. So you said domain is, yes, negative
The
infinity.
domain, -1, and then union -1, 2, union 2 to infinity.
But this and this can be joined here. Or not.
But there's another
What is that called?
horizontal, vertical asymptote between.
Vertical asymptote. Yanko, do you understand what he has said?
Hmm.
So let's come to the graph and see that again. That's wonderful, Alex. Good job.
Okay.
So here, if you look at it, you see x can assume any value except -1. Okay, then within -1 and 2, as long as 2 is not included, x can take the value because of these ones. Yes.
Mhm.
Then from 2 also, excluding 2, x can take value up to infinity. This is what it looks like from. All right. Okay. So
Yep.
yes, it's right. So the next question is, write the equations of the asymptote. Alex, equation of the asymptote.
The horizontal. Oh wait, horizontal asymptote is something that I'm troubling with. Can I say a vertical asymptote first?
Yes, of course. Anyone.
The vertical asymptote is just x equals -1 and x equals 2.
The vertical asymptote are, because there are 2 of them.
R.
Good. -1 and 2. Very good. X equals -1, x equals 2. Wonderful. Horizontal asymptote is trivia. You can look at it on the screen.
0.
But
0. Don't just say
Y
0.
equals 0.
Y equals
Y equals
0.
0.
And you see?
Mr. Daniel,
Yes.
It
apparently
crosses,
it's only
but it comes back up.
Hold on,
Oh.
Elson. Yes, Alex?
it's actually several of them because the left hand side of the graph actually extends beyond 0, and
Oh, it does?
Mhm.
Yeah, it goes
And-
under, but it comes back up.
Yeah.
Look
It
at
goes
it.
under 0. It goes under 0, but it comes back. It tends towards 0 from below.
Oh,
So
Mr. Zhang,
it's
you
y
get
equals
this.
0. Yes. Yes,
Mhm.
Elson.
If you want to see it, you need to zoom in to see how it goes under. Crosses like
Oh, I see what you
it crosses
mean.
at -5.
So yes, it's still
It's
the y
true.
equals 0. Yeah.
But then it slowly
Mhm.
tends back up to 0. So that is the asymptote.
Yes.
Mhm. Elson's correct.
Thank you, Elson. Okay, does that make sense, Alex?
Yes.
Mr. Yanko, your turn. Wait, did we answer all the question? What is the horizontal asymptote? We talked about that. Okay, no. This is the general question we all will answer. Okay, Mr. Yanko.
Okay, so for the first question is negative infinity to 3 union -3 to 2 union 2 to positive infinity.
Perfect. And the question, the asymptotes will be?
Okay, so the vertical asymptote is vertical asymptote is -3 and 2. Horizontal asymptote is y equals to 0.
When you say -3 and 2, you need to include the variable.
Equals to -3 and x equals.
X equals -3, x equals 2. Thank you very much. Mr. Iron Man. Your turn, sir.
I
This
think
is
my
cool.
graph looks the coolest. I'm just gonna put that out
Right.
there.
Right.
Everybody give my graph the badge of cool. So my domain is all real except for 0 and 4
Perfect.
because those are asymptotes.
Good.
I don't know if you need to say the range, but I'm gonna say it anyways. It's all of it because it although you can see there's an asymptote there, but it crosses, so the range is all of it.
That's true.
The horizontal asymptote is y equals to 0.
Yes.
The vertical asymptote is x equals to 0 and x equals to 4.
Perfect. Thank you, sir. Elsin, your turn.
So the range is
Whoa.
everything R. I can't tell you the range. The domain is R, and I can't tell you the range because I don't know what those points are. Oh, wait, they're,
See,
oh, it's
so
given.
much less cool than mine.
It's given. It's no, 0.281 to -1.781, which are really, really weird numbers. That's the range. And the asymptote is, the horizontal asymptote is y equals 0, and there's no vertical
Say that
asymptote.
again. Say something again about the range.
Oh, the range, if you click on the graph, it shows you the maximum and minimum points. That's what I read.
Okay. Oh, I see. So it's negative what again?
It's from 0.281 to -1.781.
It should be the other way around. The negative
Oh, really?
first.
Oh, yes, yes, okay. Like that, yes.
Good.
-1.781 to
Then the asymptotes will be
the horizontal asymptote is y equals 0, and the vertical asymptote is none.
there is no vertical asymptote. Is there a particular reason why there's no vertical asymptote here, Elsin?
I'm not sure why.
Can somebody find out b squared minus 4ac of the denominator?
It's complex.
It's complex. So there's no real solution. And you know your vertical asymptote is where your denominator equals to 0. And there is no real solution where denominator is equal to 0. So there is no vertical asymptote here.
Mhm.
And that's obvious from the shape of the graph. Thank you. For this one, it's similar together. The range will be
No, R minus,
Minus
sorry, the domain. Yeah, even the range we can determine. So the range will be everything except this range, right?
Yes.
Everything
Yes.
except -1.9 to 0.
No, there's a point
There's-
near 5.
It cross 0.
Yeah,
and
there's
it goes back
0.0,
to-
I know, but I mean, it's not including this, it's not including that.
Oh, yes. Yes.
Okay, then.
Get what I mean? So the range will be R except open interval 0 to that. Okay? Or we could say, including this interval to -infinity, including 0 to +infinity. Something like that. Understand? And the vertical asymptote are obvious: -5, x equals -5, and x equals -2. Horizontal asymptote is 0, y equals 0. And similarly here, what is the vertical asymptote? Can you see it?
X equals 3.
X equals 3.
Oh,
By
Mr.
just
Daniel,
equating this to be 0. Yes, Yanko.
it's actually me. But
Oh,
if
sorry.
you zoom out a little bit for this
Yeah.
graph, because on my screen there's a little bit of a glitch where something just pops up for a second.
What's that?
Do you see it?
What's that?
If you position, if I don't know, that's what I'm asking
There's a
you.
line
Like,
equals to 3.
Yeah, the line just looks like they meet, but they never meet actually. Can you see?
Mr. Daniel?
Yeah.
Okay.
no,
Can you look at my screen right now? This is
Oh, I see what you mean. Looks like a line
there's
pops
a line
up
in the middle. Yeah.
Whoa.
At certain spots.
Dude, where do you come from? Okay, now
Or
it's done
hopefully.
again.
No,
It's
there
done.
are certain spots. Like look at mine, Mr. Daniel. There
Yeah.
are certain spots where this is perfectly possible. Wait, I can't maneuver. Give me 1 second.
Take a screenshot, send to the group.
My screenshots are hard to take because I have two screens.
Okay, I see what you mean.
There's a line in the middle.
Yeah. But that's your x
And
equals
it's
to
in certain
3.
spots.
Yeah, that is.
That should be your x equals 3. Anyway, now let's go to, let's take this back. That's some strange shape there. Oh yeah, I see the line now.
Yeah.
Yeah.
But if you zoom, that's your asymptote actually. Maybe the graph kind of gave us that, even though we did not put that. I don't know where that came from. But we all know x equals to 3 cannot have a particular y. Okay? That's strange. Computer glitch, or what do we call that? Anyway, so look at this. Can you see the book?
Yes.
Yeah.
So number 2, for the function that looks like this, where you have linear divided by quadratic, that's why your c cannot be 0. What is the horizontal asymptote? Anyone? Or everyone?
The zeros of the quadratic at
What
the
is
bottom.
the horizontal asymptote, not
Oh,
vertical?
sorry.
A over C.
No, horizontal asymptote. Come on, look at everything we've been talking about.
Y equals 0.
Y equals 0.
Right.
Yeah. Remember, the asymptote is when x tends to infinity, right? When x tends to infinity, this will become so big. So a fraction divided by something big will be 0. We can use a limit approach to explain it, but you haven't done limits, so I'm not going to go into that because we haven't done limits. Understand? So any
Yes.
function that looks like that, sorry, I'm trying to look for my charger. Got it. Any rational function of this form, where you have linear over quadratic, the horizontal asymptote will be y equals to 0. Understand? Alex or Yanko, how can we determine the vertical asymptote?
It's the root of the quadratic equation
The root of the quadratic
at
equation, or the 0 of the quadratic expression at the denominator, because there's no equation there yet. Okay?
0 of the expression.
0 of the expression, because this is an expression, right? But when you find the 0 of the expression, you form an equation yourself by equating it to 0.
Yes.
Okay? So that's all about this. So this is the summary. For the function that looks like this, the horizontal asymptote is y is equal to 0. The vertical asymptote are the zeros of the denominator. Is that clear? So let's write that down before we look at the example. After the example, you have some questions. There are 5 questions only. So I will encourage you to do one. Okay, there are a lot of them actually. So this one you will do before we go, and the rest I will encourage you to do. I'll give you the proper worksheets when school resumes, which will be graded. Understand? Okay, so let's.
May I go to the bathroom?
Yes, sir. I'm just going to write a note while you are in the bathroom. Okay, so let's say you can take this off. So write today's dates, write rational functions. I'm being OCD with my margin. Shame on me. So So today it's Monday, 26th.
26,
Yep. Can't believe it's already
2021.
April. Can't believe it's already April. When did we start the new year? Everything moves so fast. So rational functions. Of the form okay, so from investigation. So basically our objective, which we have been able to achieve now, I just want to write this. Okay, for the notes. So find the asymptotes of should be able to and the asymptote of f of x of the rational function. Let's put it that way. I don't want to repeat the form of the rational function. I'm too lazy. And 2, sketch. See first. So from our investigation, we discover that for any rational function of the form ax plus b cx squared plus dx plus e, where c is non-zero, the horizontal asymptote is always y is equal to 0. The vertical asymptote, if any. Can somebody tell me why I use the word if any?
Because the
Because
risk of the
Elson's
complex.
case.
The case of Elson, we realize that there is none, right?
Mhm.
Okay, if any are the zeros, the zeros of the quadratic at the denominator, which is cx squared plus dx plus e. Thanks. Just to have a notes, okay? Ready?
Yep.
Okay, so let's listen to an example. It's going to be a combination of what we have said and something you have done in the past. So please listen attentively. Okay, I don't think I shared the audio, so I'm going to share. Okay, so give me thumbs up if you can hear once I start playing it.
We have already studied rational functions of the form linear over linear. We saw that these functions had both a horizontal and a vertical asymptote. We now consider a rational function of the form linear over quadratic. For rational functions of this form, the x-axis is always the horizontal asymptote. We know that a quadratic may have 0, 1, or 2 real zeros. This form of rational function will therefore have 0, 1, or 2 vertical asymptotes. In this case, the function is undefined when the denominator is 0. We factorize the quadratic and find there are two solutions. So there are two vertical asymptotes, x equals -1 and x equals 4. In part B, we find the y-intercept by substituting x equals 0. In both the numerator and denominator, the only non-zero terms are the constants. So the y-intercept is 3 over 2. X-intercepts can only occur when y is 0. This means the numerator must be 0, and this occurs when x is 3.
Does this make sense so far? Yes? For your vertical, it is y equals to 0. Horizontal is when denominator is equal to 0. You solve, you get to x values. For your axis-intercept, it says axis-intercept, meaning x-intercept and y-intercept. So it's both of them. Understand, this is plural, axis-intercept. X-intercept is when y is equal to 0. Y-intercept is when x is equal to 0. If x is equal to 0, all the x terms will be 0, leaving only -6 and -4. That's what you have here. And when y is equal to 0, a fraction is equal to 0 when the numerator is equal to 0. Do you agree? So that is why you can write directly, equate the numerator to be equal to 0. So you don't have to say this is equal to 0, cross multiply. You are welcome to say when y is equal to 0, the numerator here is equal to 0. And then you get the option. Okay, so let's move on.
To draw a sine diagram of the function, the critical values include the x-intercept 3 and the vertical asymptotes at -1 and 4.
They must be arranged in order. -1, 3, 4. You use broken lines for the asymptote. You use thick line for the x-intercept. This is the x-axis. So this broken line means it doesn't have any value of x equals -1 and x equals 4. That's why there are broken lines. But it does cross the x-axis at 3 because of your x-intercept is 3. Does that make sense? All right, so.
Yeah.
When x is large and positive, both the numerator and denominator are positive, and so the function is positive. Each factor is single, so the signs alternate.
Does this make sense? Pick a very large number, more than 4. All this will be positive, so this side is positive. And these factors are alternating, they are linear and not repeated. Do you remember? If your factors are linear and distinct, you remember rational function we did with the general class?
Yes.
Then you will have alternating factors. So instead of substituting for each range, as long as you have, distinct linear factors, once you get a particular point, the rest will be alternating. Does this make sense? If it is quadratic,
Yes.
maybe all squared is not going to be the same. All right.
The sine diagram helps us describe the behavior of the function near the asymptotes. to the left of -1, the function is negative. So as x tends to -1 from the left, the function tends to -infinity. Just to the right of -1, the function is positive. So as x tends to -1 from the right, the function tends to infinity. Just to the left of 4, the function is negative. So as x tends to 4 from the left, the function tends to -infinity.
Understand?
To the right
Mhm.
of 4, the function is positive. So as x tends to 4 from the right, the function tends to infinity. As x tends to -infinity, the three factors in the numerator and denominator are negative. So the graph is negative, and it approaches 0 from below.
Understand that?
Mhm.
Negative infinity.
Yeah.
So this will be negative, this will be negative, this will be negative. All right? And when you substitute infinity, normally it should be 0. That is the whole idea of the y asymptote, of the, horizontal asymptote. When x becomes large, everything becomes 0. But it becomes 0 from the negative because of this negative that everything becomes. Understand?
Yeah.
Elsin, Yanko, Carter, do you understand?
Yes.
Yeah, I understand.
Elsin, understand?
Yes.
Okay, Yanko,
Yes.
Yeah.
Alex?
Yes.
Okay, great.
As x tends to +infinity, the
There you see, for plus infinity, everything will become plus infinity as well, right? And because this will be very large, that will be 0 also. Because denominator, when denominator becomes large, everything becomes 0. Understand that? So when that everything becomes 0, but because each factor will become positive, infinity, it will be 0 from positive.
three factors in the numerator and denominator are positive. So the graph is positive, and it approaches 0 from above. We now use all the information we have gathered to draw the graph of the function. The x-axis is the horizontal asymptote, and we add the vertical asymptotes. We mark the x-intercept and y-intercept. We next mark what happens near the asymptotes, either side of x equals -1, either side of x equals 4, and as x tends to -infinity and +infinity. We can now connect this information using 3 smooth curves. Remember that a graph can never cross a vertical asymptote, so the graph must have 3 separate branches.
Does this make sense?
Yes.
Yes.
Yeah.
Alex, ask your question, please.
Yes.
Okay, so everybody's good? So I'll send a screenshot of this also. So please write down the example in your notebook. Understand? So
Mhm.
let's go back
Yeah.
to the book. So here is one.
Mr. Daniel, my
graph.
brother, just fine. Give me a second.
Yeah, this graph is shown already. Find the asymptote and find the axis intercept. I want you to do that in your book and let me have it. Leave a space for the example.
Okay.
Okay, leave space for the example because I want you to copy the example. This is the example. So leave enough space, please, for the example. Then I want you to do this question 1 and send to me on WeChat. You have 5 minutes max. Done?
No, not yet.
Okay. Don't worry, take your time.
Mr. Daniel, do we send it
Yes.
to you one by one or the whole question?
Say that again?
Do we send the answers to you one by one or just give you the whole question?
A and B together.
Okay.
Or if you prefer to send one by one, it's fine. Got something? Okay, got two things. Oh, it's not from you guys. It's from someone in Form 3. Can they leave me alone? It's break time.
I mean, we're not leaving you alone.
I know, right? They won't just leave me alone. It's break time. They're supposed to be on holiday. Leave me alone, Form 3. Almost done?
Yes.
I'm sending it to you now. In a personal message, right? Not in the group chat. Mr. Daniel,
Yes, sir.
we send it in a personal message, right? Private message.
Yes, sir. Private message is fine. Got it. Yeah, that's correct. The x-intercept is when y is equal to 0 LC, not when numerator is equal to 0. You have to justify why you're equating numerator is equal to 0. So just stick to that. The x-intercept is when y is equal to 0. Then you may now add that when the numerator is equal to 0, but you don't have to go into all the details. All right. And the y-intercept is when x is equal to 0. When x is equal to 0, you only pick the numerator LCM. What about your denominator? So the second intercept is wrong, sir. Please check. Make it simple. Your work sometimes is complicated. Make it simple. Alex got it. Horizontal asymptote is correct. Vertical asymptote is correct. There is no x-axis. Nobody asked for x-axis. The question is x-intercept. You cannot find the x-axis. So,
Okay.
so you could write x-axis intersect because it says axis intersect. So if you want to write x-axis intersect, or just say for x-intercept, y is equal to 0, then you can work it out. For y-intercept, x is equal to 0, then you can work it out like that. Okay? But the answers are correct. That's the presentation. Yanko, I'm waiting for you. So while I'm waiting for Yanko, I'm going to be sending the screenshots to the group. Oh, okay. Is that Yanko? Yes. I'm really struggling to see Yanko. If you are sending the whole book, you can take 2 photos so that you can have a close shot next time.
Okay.
All right. So, and Yanko, I can see why your work is delayed. You first took time to write the question down.
Yeah. Like,
for online class, don't do that. Just leave the space so that we can move fast, not waiting for you to copy question down.
okay.
Is that clear?
Yes.
Y-intercept, so find the x-intercept. Y-intercept, you just say y is equal to -5/2. How did you get that?
Oh, okay. I should
Then
clarify.
x-intercept is when y is equal to 0. Then you said when denominator is 0. No, not when denominator is 0. When y is equal to 0, which implies when numerator is equal to 0.
Yeah.
And your numerator is equal to 0, then you said x-intercept before x minus 5. That's not the x-intercept. That's not the x-intercept.
Right.
Please check the example again and fix this. So I'm going to send you this page. One sec. Can you see the screen, Yanko?
Yeah.
Can you see? So the intercept is not 2x minus 6. It is the value of x when 2x minus 6 is 0.
Yeah. Yeah.
So please fix that.
Okay.
So I've put the example there for you. Put the screenshots of the questions. So please use the example to solve about 5 questions from question 2 between now and next time. If you have more time, you may try question from number 3 to 5. And that would be all. Let me see. I want to send this in one page. Yeah, I got it. I'm good. Okay, so I will be giving you some questions, like I said. It's possible I type it out and I just send to you to print and do the needful. Okay, it's possible I do that. I think I have a question like this from last year, so I'm just going to edit that and send to you guys. So expect that later today, I guess. Expect that later today. Okay, guys.
Should we remind you or
Yeah, that would be nice. If in case I forget, just send me a reminder. Thank you
Okay,
so
so
much.
I'll
That
remind
was very good.
you
Say
dinner
in few
time at
hours
7.
time.
A few hours. Okay.
Yeah, or evening, it doesn't matter. Any questions
okay.
before I close the class? So I'll see you on Thursday. Ahead of Thursday, I need you to review how to use division of polynomials.
Okay.
So if anyone
Okay.
has forgotten division of polynomials, go back to your notes and review division of polynomial. That was the main
Okay.
reason I did polynomial. Apart from finding roots and all the fundamental theorem of algebra we learned, another application of that is finding asymptote, because we'll be dealing with asymptote that is slants. Okay, we'll be dealing with asymptote that is slants. So I'll see you on Thursday from my staycation. Bye.
Bye.
Bye.